Hello guys, welcome to today's video. So today we'll be seeing something about fault, the difference between fault and failure from a system design perspective. So as the name suggests, as the term suggests, fault is nothing but a state when a particular component in a system, the component in a system goes out of its spec. So this is the technical definition of a fault. So when a particular component goes out of spec, for example, I can take a particular service within a particular system. There is a large system out there, and this is a small service within that particular system, and it actually does some sort of processing, and it gives out some results. So let's assume that this particular service, the throughput of this particular service, is 1,000 requests per second. If this is the throughput expected out of this service, then if after some days of operation, the throughput of this particular service drops down to say 800 requests per second, then we can actually say that this particular service has gone out of its spec. In that case, we can technically say that this service is in a faulty state. So the reason why this particular service has become a faulty state, there can be many number of reasons associated to that particular uh, cause of associated for that particular service to be in a faulty state. So there can be many number of reasons. One of the reasons could be a hardware reason. Some of the hardware component that particular service relies on is has become faulty or has become is operating out of its spec. For example, the hard disk has become faulty, or some hardware component in that particular system has become faulty. In that case, we can say that this particular uh, component is faulty because of a hardware fault. There is something called as network fault. For example, some network components, or there is a network drop, or there is a packet drop while communication from the host machine to a remote machine, then we can say that there is a network fault. The reason of these faults can be very many reasons can be there. It can be a human induced fault, wherein a particular operator of a particular system or a particular component has given wrong configuration inputs to that particular system. So in that case, the system or that particular component will behave in a fashion that is not expected of it. So in that case, that particular component will become faulty because of a human error which was induced. So there can be very many reasons associated with it. And as you can see that these situations are not completely unavoidable. So this will happen uh, at any point in time during the operation of that particular system. So as a skilled developer or as a skilled system engineer or as a system design engineer, what we have to do is we have to design our system in such a manner that it can tolerate some of these faults. So, so here comes the concept of something called as fault tolerant system. So this term is coined from the assumptions that some of these faults can't be prevented. It cannot be prevented, and it will happen at some point in time. So it is imperative that our system can tolerate some of these faults so that this will not lead to a failure. So the term failure means the system becomes non-responsive for any of its requests, and it will not be able to deliver any of its requests, or it will not be able to give a response for any of its requests. So it will be completely unresponsive. The system will completely go unresponsive. So there are different ways with which we can tolerate the fault. It depends upon the type of fault which we want to tolerate. For example, we can take an example of a network fault. So we are aware that during the communication from one machine to another over a particular network channel, there can be packet drops. So there can be packet drops. So this is the assumptions. This thing we already know that this can happen in the future. So what can we do to prevent or tolerate this particular packet drop? So what can we can do is we can actually try to monitor the packets that we are sending through the network. So we can actually monitor the packets that we are sending through the network, and we can actually at the receiver side monitor whether we have received all the packets that we have sent. If not, we can retry the transmission. We can do a retry of the transmission. So this is something known as a fault tolerant design. So what we are trying to tolerate here, we are trying to tolerate a network failure or network packet drop here. So this is one type of fault tolerant design to tolerate a network fault. There are other design choices that we need to make to tolerate different types of fault. So essentially, what I meant to say is fault is not cannot be completely prevented or cannot be completely avoided. So it is up to the system engineer to design a fault tolerant system such that the system will not go into a failure state. So our main goal or our main aim is that the system should never go into a failure state, whatever fault happens. So whatever fault that we can foresee, if we are able to design our system in such a manner that we are able to tolerate some of those faults, then our system will not go into a failure state. And this will ensure that the customer will be satisfied with our system usage. So this is what I want to discuss in this particular short video.